size is important when the population is not normally distributed. Increasing sample size decreases the dispersions of the sampling distribution. Or the sampling distributions of the sample mean is approximately normally distributed. Or the last one, the sampling distributions of the sample mean will be skewed. Doesn't matter left or right. So which one? Which answer do you think is close to explain the central limit theorem?
Number 3.
Number
3.
Okay, so let's see what central limit theorem says. I hope that you can see my right hand side notes, which is on central limit theorem. So this is let's just read the green box. Normally the green box will summarize everything about the theory. So it says that if samples of a particular size are selected from any population, the sampling distributions of the sample mean is approximately a normal distribution. So what do we mean by normal distribution? You will have like a normal curve, a bell-shaped curve. And the approximation improve with increase in the sample size or larger sample. Okay, so this is what central limit theorem says. So which one? It is approximately normally distributed. So the answer is number 3. Okay. Okay, next one. So let's just focus on the easy question first. So the section 6, the same question. So which answer do you think that is close to explain the central limit theorem? The sample size is important when the population is not normally distributed. Increasing the sample size decreases the dispersions of the sampling distribution. Sampling distributions of the sample mean is uniform. Or sampling distributions of the sample mean will be skewed. Which one?
Based on my understanding, I think the answer is number 1.
Anyone else?
Number 3.
Number 1.
I also think number 1.
Okay. The sample size is important when
Number
the
2.
population. Number 2. Okay. So there are like all answers are possible, right? So what is the meanings of uniform? Have we learned uniform? We haven't learned uniform, right? It is is it in this chapter? Let me see. No. So when you look at the overview, it is not under here. So uniform is chapter 9. We haven't learned uniform. And well, basically, uniform is a statistic word. So we haven't learned it, so it shouldn't be the answer. Where is the central limit theorem? Where is it? Okay, let me stick to this. Okay, so as I mentioned to you, the sampling distributions of the sample mean is approximately a normal distribution. So normally the sampling distribution will be normal, close to normal. Approximate means it is close to normal. And the estimation improves with larger samples. So when you estimate and you have a larger samples, definitely your estimation will be better. Okay, can you see that? So which one? Your estimation will be better, will improve with a larger sample size. So can you see which one is explaining that?
Number 1.
Number 2.
Number 2.
Okay, so increasing the sample size, as I mentioned to you, the estimation will be better, will improve with larger sample. So increase means that when you keep increasing the sample, you will have okay, where is it? it says that when you central limit theorem says that your estimation will close to normal distribution, right? Okay, and then when you keep increasing the sample size, the n, basically your estimation will be better. So increasing the sample size will definitely decrease the dispersion. Dispersion means the standard deviations or the variance, means that your estimation will be better. Okay, so got it? So regardless of the sample size, well, normally we will have a normal distribution shape. Okay, so if you look at here, let me show here. Okay, maybe I should make it bigger, right? So this is central limit theorem. So if you look at here, the population, okay, I shouldn't expect, okay, let me respond to this, or else someone will not know that I have class. They will keep, okay, in class. Ayo. Okay, where is it? Where are we? Okay, so this is the population. Your population will not look like normal. You're gonna have like different shapes of population. Okay, regardless of the population, your sampling distribution, your sample will look like normal. And you can see that the more you increase the sample size, the more it will look like a normal shape, normal distribution. Okay, can you see? So you can see that your population have different shape, which is not normal. But then, regardless of the n, you will look. They will look like normal. And the more you increase the n, the more you increase the sample, the more it may look like normal. Okay. So if you look at here, n equals to 6 and n equals to 30, which one is more normal? The 6 or the 30?
6.
30.
Why 30?
There's less
Because
variance.
the dispersion.
Because it less
The
variation.
dispersion is small. Okay, even though you may say, okay, the 6 may look like the bell curve shape, but actually in statistics we want the curve to have a less dispersion. Less dispersion means less standard deviations or less error. So the we call it, the narrower it is, the lower its standard deviation it will be. Okay, so regardless of how many n's, you will look like normal, and the more n, you will have the better estimation. That is what central limit theorem says. Okay, got it? Is it clear?
Madam, wouldn't increasing the sample size become closer to the population size? So like, wouldn't it not look more normal? It should look more like the population.
When you increase the sample size, it will look like population. Yeah, it will look like population, but of course, it is hard to definitely get the total population. Normally, it is almost impossible. Okay, so it says that regardless of the shapes of the population, so this is the theory. When you keep increasing the sample size, you will be closer to normal, even though somehow your population may not be normal. Okay, so we
like,
assume.
like if the population, let's say it's like 50, and then we take a sample size of like 30, wouldn't it look more like the population, and then it's not like a bell curve?
No, if your sample is
What if we take
30,
a sample size of 50 then?
50,
Would
no.
it look?
So, okay, so population normally billions or millions in number.
Oh,
Okay, so
okay.
you shouldn't get the population shape. So that's why they said when you keep increasing the number, the sample size, you will have a nice bell curve, like a normal bell curve, regardless of the shape of the population. So we always assume the population is normal, even though sometimes the population is not normal. Okay?
Oh, okay. Thank you, madam. Because
Mhm.
I found the similar question in the homework.
Okay. We assume that when we keep increasing the sample size, we will have a very nice normal bell curve shape. But Remember, the population may not be normal, but we assume that so that it is easy for us to estimate later on. Of course, we cannot estimate the population. It is impossible. Okay. Almost impossible. It is possible, but it will be time consuming, expensive, and many other things. That's why normally people will work with the sample. Okay. Okay. Next. Okay, that is about the central limit theorem. I hope that everyone is clear. Any question regarding central limit theorem before we move to your favorite question? Anything else you want to ask? No. Okay. Silence means everyone is clear. Cool. Okay. So I got too much. Let me open. Okay. So here I put like, where is it? This one. Okay. So this question is basically similar to both sections, so that everyone should get the same question. So I want to see how would you think about this question, because normally I would love to give you a very straightforward question, right? But if you look at this chapter, okay, when I look at the overall of this chapter, I didn't even like study this chapter because this is not my quiz. So when I look at this chapter, let me go from the first. Okay, so how many calculation do you have? You don't have calculation here. No. This is just to compute the mean, which is not even, well, it's the previous chapter. What else? The theory of central limit theorem. Okay, you have one formula here, standard error of the mean. The formula is sigma over square root of n, just two variables. And then normal distribution. That's it. You only have two questions. So in order for you to compute the z, you have to have all this information. X bar, which is your sample mean, mu, which is your population mean, sigma, population standard deviation, and n. So you have to have all this information, and then you should get the z and the probability. So that's it. Well, this what we call this chapter is like too easy. So when I look at the question, I think that, well, perhaps we should take something a bit slightly not direct forward. Okay, so this is the question. Okay, some of the previous section some of them got correct, which is good. Let's see your performance as well. Okay, so Rolex annual reports says that the average Malaysian buy 6.5 of watches per year. So suppose, comma, not S, the samples of 81 customers. Okay, maybe we should do it slowly. Okay, put it here. Okay, so let's answer this together. Okay, so the average Malaysian buys 6.5 of watches. So what is that 6.5?
Mu.
Okay, so I don't have to explain to you what is mu, 6.5. And then suppose samples of 81 customers. What is that 81?
N.
Okay, next is survey and the population standard deviation. So this is your sigma 2.1. Okay, so you should know how to transform all these statistical words into what we call a symbol. I think it is easier rather than writing the population mean, the sample, blah, blah, blah. So this is a simple form. Okay, so what is the probability that the difference between the sample mean and the population mean is less than 0.25? Okay, so how to answer this question? So let me draw a diagram first. What is the middle?
6.5.
6.5.
Okay, so you want to find out the difference between the sample mean, the X bar, and the population mean, the mu, is 0.25. So how to find the difference is 0.25? difference between this and this is 0.25. So 6.5 minus 0.25 equals to what? Anyone have a calculator?
6.25.
0.25.
6.25.
6.25.
Okay. Okay. So regardless whether you minus or you plus with 0.25, you should get the difference of this, right? So if you plus 6.5 with 0.25, what should you get?
6.75. 6.75.
Okay, so yeah, so regardless whether you minus or you plus the number, you will get the difference is 0.25. So this is what the question means. So it wants to find this area. So 6.25 and 6.75. So it wants to find the probability that the difference is the difference between the population mean and the sample mean is 0.25. So you minus or you plus, the difference will give you the same thing. Okay, so your X bar, your sample mean will have two values, which is 6.25 and 6.75. Okay, so now, so far so good?
Yes.
Okay, so you want to find these two areas. So can you help me how to find it? What is the formula for computing the Z for normal distribution? Where should I write it? Oh, maybe I should find
X bar.
X bar. And then?
Minus
Minus population mean.
mu.
And then? Okay, now
And
some of you are looking for the notes. Okay, so you have two values here, right? You have two areas. So the first X bar is 6.25. And then you minus mu. What is your mu? 6.5 over sigma. What is sigma? 2.1 over square. 2 point. This is point over square of, what is that? N. N is 81. So you want to find these two areas. So I just plus these two areas. The second X bar is 6.75 minus your mu 6.5 over the same thing, sigma 2.1 over square root of n, 81. So the first working will give you the value of
Negative
Negative
1.07.
1.07. Okay. So some of you maybe take the 0.25 here. Instead of minus this, maybe you will take 0.25 because you look at the difference, right? The difference between sample means and population mean is 0.25. So you may take this value. I still can consider that. Okay. And then the second one, because the difference are the same, but because this is larger compared to this one, you will have a positive number, which is 1.07. So is this the probability?
No.
No.
Value. So you have to convert into probability. So we have to look at the table. Z table 1.07. So 1.0 and then 7. I'm assuming that you can see my cursor and my table. 1.07. Where is 7? Ting, 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 ting. So 0.3577. Okay, remember that. 0.3577. So because these two are the same number, so you can multiply with 2, or you can still plus the same number, 0.3577. So this should give you the value of 0.7154. Okay, so these, where is my cursor? These are the area which is equivalent to 0.7154. Okay, some of you maybe just give one answer. Where is it? This part. So I will consider like a half marks. Means that in total, okay, if you look at the question, So the first part, well, the total marks is 2. The first part will give you half. The second part will give you 1.5, right? So, well, definitely I will consider as I mentioned to you in the previous discussion, if you want to solve this kind of question, you have to have a diagram so that it can help you to somehow determine which area are we talking about. So the diagram will give you 0.5, the first working will give you 0.5, the second working will give you 0.5. Okay, so for those who instead of taking the whole number, the exact number, and you just take the difference which is mentioned in the question 0.25 over the sigma and everything, you still get your 0.5. Okay, so I will consider all the possible correct answer. So don't worry too much about it. Okay, so any question regarding this before we see the other sets of questions? So any question from the two section? Anyone? No. So when you keep silent, I'm assuming that it is there. Okay. Can I move to the next sets of questions?
Yes.
Yes.
Okay. So okay. So I will close your question. This is section 5, and section 6 also the same question. So I will just close it. Okay, let me remind everyone, if let's say somehow I don't know what happened, you got up late or whatever, please still do the quiz. Even though you cannot answer the quiz, just do it. Because your quiz is also part of your attendance. So remember, attendance is very important. If you miss more than 3 times, you will get a warning letter. This is like a procedure in the university. So you have to somehow attend the quiz. Okay, if you couldn't, then please let me know. You have to provide an excuse letter or whatever letter you have. And if it is deemed to be valid, then I will consider that. Okay, so okay, this is for the section 1. I talk too much. Okay, oh no. This is the exercise. Okay. So put it here. So make sure. So the first question, I will just leave it to everyone to answer it. What is the difference between a sample mean and the population mean called? What do you call it?
Sampling error.
Sampling error.
Very good, very good. Because I saw many of them answered standard error of the mean. So I was like, oh, okay, I thought that this is very straightforward. Maybe not, I'm not sure. I think it is very straightforward. Is it straightforward or not straightforward?
It's easy question.
Compared to the theorem.
You know, yours is maybe also straightforward because everything is given in the green box, right? They will also tell the same. For us, it is not straightforward. If you look at the definitions of simple random sampling, so it says that the simple random. No, I'm looking for error, sampling error. Where is it? Okay. So if you look at the definition in the green box, well, normally green box will tell everything. The difference between the sample statistics and population parameter. So they may also say that, well, this is saying sample statistic, not sample mean, and it says population parameter, not population mean. Even though I have mentioned in the video, I said sample statistic is sample mean, your X bar. Yeah, right. So it is very direct. The same with your question as well. The way how you look at it, I'm not sure. Okay. Because many of them answered standard error of the mean. So I'm not sure why. It is there. It's just that how you understand it. Okay. So the second part, is this yours? No, this is that. Okay. I don't know whether you can answer this. Let's look at it together. Zato wants to collect data for her statistic assignment. She goes to shopping malls and randomly interviews anyone she meets. What types of sampling method she uses? Tell me. Random. Anyone else?
Simple random sampling.
Systematic.
Anyone else? I cannot hear. I can only hear random sampling. What else?
Is it cluster because of the shopping mall?
Cluster.
No.
Simple random method.
What?
Systematic.
Systematic, no. Okay. So in this case, the answer is convenient. Okay. So they will also complain about this. They said, if you look at the slide, it is not given there. You have simple random sampling, systematic, stratified, cluster. Where is the convenient? Okay, this is my explanation. In statistics, we only recognize these 4 methods of sampling method. We call it probability sampling method. Why it's become probability? Because this is the right way of the statistician to compute their probability estimation. However, outside our field of studies, we have human science, we have engineering, we have many other field of studies. So they may not know how we estimate it, because for us, we want to make sure that our estimation should be statistically significant. We want to make sure that our estimation is somehow has a less error, right? That's why we have a specific ways on collecting our data. For them, they don't really care. They can just go anywhere and meet anyone and collect the data. And they call it convenience. They can also call it what else? Snowballing. Anyone can become your respondents. They can also call it what we call it. What else? They call. I forgot. There are many names for their data collection, which is not recognized by our field of study because it will not give us statistically significant result. Okay, so in this case, why it is not a random sampling, even though you put random? So random here is the normal English terms for means that whenever you meet someone, randomly you will interview them. But in statistics, it is not called as random. For random, okay, so let's see the notes. Because I didn't study the notes, you are the one who studied the notes. So for random, you have to have a list of names to begin with. If you look at the example, okay, so let's look at the green box first. Green box is always important. Simple random sampling means that a sample selected so that each items or persons in the population has the same chance of being selected. So if you go to any shopping mall, you will just select anyone. So not everyone will have the same chance of being interviewed by you. So it is biased because sometimes when you go to shopping mall, for example, shopping mall A, so people in the shopping mall B will not have the same chance to be selected because you are in shopping mall A, right? And if let's say you are in shopping mall A, you are in second floor, people in the third floor will not have the same chance to be selected because you are in the second floor. So can you see that what kind of methods is she using? In this example, Zatul, right? So this is just an example. So okay, for simple random sampling, you have to have a list to begin with, list of names. So if you look at the example here, there are 750 baseball players. So you have a names of, or you have a number of 750, doesn't matter, names or number. Basically, you have the list. And then you want to form a committee of 10 players. So in a traditional method, what we did, we put all these 750 players' names or number in a box, and then someone will pick 1 or 10 numbers to find the committee. So basically, all these 750 people have the same chance of being picked by you, right? Because you put their names or their number in a box, so you can just take anyone from that list. So they all will have the same chance of being selected. But if they are not there, how can they have the chance of being selected? That is one characteristic of simple random sampling. Second, okay, so if you look at here, if you don't have list of entire population to begin with. So if you don't have the list, definitely you cannot use simple random sampling. You have to use other types of sampling. But the other types of sampling method will also have different characteristics. And in this question, you don't have any characteristic, right? You just somehow using the English word randomly interview anyone you meet. If let's say you meet the person in the toilet, you just interview that person. If you meet someone, well, maybe that person seems nice, you just interview that person. So you didn't have this, you didn't offer the same chance of to everyone to be interviewed. Okay, got it. Are you happy to get this question? Okay, so this is question for section 2. Okay, so the last one. So this is very similar with your question. So if you have understood what I have explained before in your question, you should be able to answer this question. So not this one. Painting, please. Okay. So let's answer this together because I don't remember the answer already. So Sabrina, an analyst, uses the price of chili as a measure of inflation. Well, remember, inflation, we can use any price of goods to measure inflation. Okay, what is inflation in the first place? Can anyone tell me about inflation?
Increasing price.
The increase in the overall price. So if you have inflation, are you happy with it?
No.
No,
Why you are not happy?
because everything is expensive and
Very expensive.
yeah.
Is that how the economic students should answer? Yes, everything will be expensive. And what does it mean?
Our purchasing power is
Yes,
dropped. Yeah.
your purchasing power will decrease, right? So remember previous topic we talked about how to compute the purchasing power of the dollar. So when you have the inflation, definitely your purchasing power will reduce. Purchasing power will measure how many items you can purchase using your current income. Okay, so she finds that the average price is 3.82. What is this? What is this 3.82? What should I write?
Mu.
The average price, the mu, is 3.82. And the population standard deviation is, the sigma is 0.33. You decide to sample 40 stores. What is this 40?
And
And
Okay. And collect their prices for a grams of chili and compute the mean price for the sample. What is the probability that the difference between the sample means and the population mean is less than 0.01? Okay. So can you answer this question?
Yes.
How? The mu is 3.82. You want to know that the difference between sample mean and population mean is 0.01. So how to find the x bar? 3.82 plus minus with
0.01.
0.01.
yes. So your x bar will be what is it? If you minus it, you will get 3.81. If you plus, you will get 3.83. So this area, 3.81 and 3.83. So you want to find these two areas. Okay, can you find the areas? It should be easy, right? Should I write the working here? What? Waiting for the answer. Should I write the working or you should know the answer?
We should know the answer.
Everyone is fine with that? Should I write the working or I shouldn't write the working? Which one?
Write the working, madam.
Okay. So you have to use the formula of okay. So what is the formula? You have to use Z equals to what? Well, this formula is very simple. You should remember it by heart. So the first x what? 3.81 minus the mu 3.82 over sigma 0.33 over square root of n 40. And because you want to know the middle, these two areas, so I will just plus the second x bar, which is 3.83 minus the mu 3.82 over the same thing 0.33 over square root of 40. So the first calculation will give you the value of, I don't remember, negative 0.19, and the second looking should give you the same thing, which is positive 0.19. So these two, when you look at into the z table, this is the value of z, okay? It is not your probability. So when you look at the z table, you should get the value of 0.0753. Because these two are the same thing, normally I will just multiply with 2. You can just plus these two numbers. Okay, it's up to you. So it should give you the value of 0.1506. Okay, so if let's say, well, this is the same thing, just a repetition of what you have. Okay, basically the same question. If let's say you have the, where is it? The question, instead of less than 0.01, they said, what is the probability that the difference between the sample means and the population mean is more than 0.0? Is this your question? 0.01. Instead of less, it become more. Which area in the diagram you should plot?
The right side.
Huh? The right side.
Yes.
The right side in this side or this side? Which one? Number 1 or number 2?
Wahidun.
Why?
Number 1. Okay. So, okay. Just to make it clear, that's why I mentioned this, because the morning class asked me the same thing. So I also want to make sure that you also get the same understanding. Okay, if you look at here, what is the probability that the difference? So we want to know the difference between the sample mean, the x bar, and mu is this, is 0.01. If let's say we talk about less means that the bigger number minus the smaller number, so you get less. Less or more are the same thing. You just want to know mu minus your x bar, you will get the value of 0.01, regardless of less or more, because it's just a matter of you plus or you minus. Which one minus which one? Then you will get more or you will get less. Okay? So less or more will give you the same area, this middle area. Okay? Sometimes you may want to take mu minus x bar, or you may take x bar minus mu. They will give you the same answer, regardless negative or positive, the same thing. Okay? And another tricky part, just to mention, because in the morning class we also mentioned about it. So they may also ask you, what is the probability? Instead of asking the difference between sample means and population mean, the question can ask you, what is the probability that the difference, when we talk about difference, it shows the changes, the difference between something, right? So they, in this case, they put the difference between in the sampling, what we call sampling error. Is that the term? Yeah, sampling error. What is the probability that the difference in the sampling error is more or less 0.01? So sampling error, what is sampling error? You are still talking about the same thing, the difference between your x bar and your mu. Okay, so they can also ask you in that form. So next time when you see that they ask about sampling error, don't get panic. Basically, we are talking about the same thing, difference between sample mean and population mean. Okay, got it? Okay, I hope so. So basically, all the questions in this chapter 8 are very easy. So when I look at this question, oh, it's slightly not really tricky, slightly less direct forward. So I think that maybe it's good to check your understanding. Okay. So anything else before we end our class? Any question you want to ask to make sure that you have understood everything?
No, madam.
No, well, cool. Anyone else? Anything?
No, madam.